In this section, we will review the inappropriate use of a calibration model to compensate for not performing maintenance. The U.S. EPA has long understood the possibility that certain nonlinear calibration models would tend to mask certain analytical problems and thus compensate for not performing the necessary maintenance on an instrument. Since at least 1996, the SW846 methods under Method 8000 have contained a similar statement as presented in this slide with the newly promulgated Method 8000C in the Arizona regulations. What does this really mean to an analyst? Is it inappropriate to use nonlinear curves or to ever switch a calibration model for an analyte? The answer to both of these questions is no. Does this only apply to hazardous waste? While this note only applies to SW846 8000 methods, the effect that is being talked about by the EPA would be observed also in drinking water, wastewater, and air analyses, mainly with organic analytes. It is hoped that the following real example with a drinking water analyte will demonstrate what is meant by these statements. In this slide, the first 10 minutes of the hard copy total ion chromatograms from 3 different analysis runs over about 9 months are presented. The first chromatogram is from May 30th of 2001, when the method was first set up on the GC mass spec instrument for EPA method 524.2. The peaks have sharp resolution and high responses. In January of 2002, when the lab began to ramp up its testing with the instrument, a January 18, 2002 chromatogram shows that the peaks have lost as much as half of their response, and chloromethane and vinyl chloride are beginning to collude. Within just 1 more month, the peaks have lost 75% of their previous month's response, with many of the peaks colluding. A review of the lab's method by ADHS showed that the split ratio on the instrument had been set by the lab very low, allowing water to pass onto the column, washing out the beginning peak's chromatography. The water also had the detrimental effect of destroying the mass spec filament, which was the cause of the loss of peak response. Some of the effects on individual compounds that this water problem was having on the chromatography can be shown by the tailing of the internal standard fluorobenzene peak, the coelution of another peak with the surrogate 1,2-dichlorobenzene D4 peak, and the splitting of the vinyl chloride peak. The loss of peak area response caused by the destruction of the mass spec filament by the water can be observed by reviewing the hard copy quantitation reports for May 30th of 2001 and January 18th of 2002 with the internal standard fluorobenzene response beginning at 1,289,020 and declining by 72% to a response of 359,679 in 8 months. In January of 2002, the analysts began to manually integrate the surrogate 1,2-dichlorobenzene D4 peak due to coelution. This response decline can further be shown by a decrease of an additional 11% of the internal standard fluorobenzene response from 359,679 to 216,205 for a total of an 83% decline since the method was developed. In addition, the analysts had begun to manually integrate numerous peaks due to the loss of resolution of the peaks. Now we will bring this discussion back to the topic of this section, which is the inappropriate use of calibration models to compensate for not performing maintenance. Obviously, the lab was experiencing severe problems with this GC mass spec instrument, which required maintenance. However, the analysts admitted to ADHS that they did not know what the problem was with the instrument. One of the actions that the analysts used to pass the method required calibration and quality control criterion, despite the instrument problems, was by flipping the calibration model from linear to quadratic. In the November 2nd, 2001 update of the 524.2 method, all analytes are set to linear. Over the next 3 months on the method update from February 27th of 2002, more than half of the analytes had increasingly been set to quadratic. The February 27th method update of vinyl chloride shows that the analytes' responses would no longer pass the method requirements for a linear calibration curve. However, since the calibration points were set to a quadratic fit, the analyst was able to meet the method criteria and proceeded to quantitate samples. While this quadratic curve for vinyl chloride appears to be acceptable, it is the result of inappropriate manual integrations on poor chromatography noisy split peaks. This masks the fact that maintenance needed to be performed.